Hello students. So we continue with the lathe topic we discussed. Now we'll take up a case study. Okay. So I'm having pieces with me actually. These are pieces used in industry. Okay. So this may be used as a turnkey or something. Okay. Turnkey is that when you place it in the insert and you rotate it, it will open something. Okay. It's similar to your key which you're using for your home. So this is used in some machines. Okay, either it may be used for fastening or some purpose. Okay. The next thing is this may be some shaft. Okay. So what we have to analyze in today's case is that we'll take up these materials and analyze what are the materials for this, what are the process we can use to machine these things. Okay. So since we are dealing with say we'll analyze what are the tools used, what are the machine used. Like that we can move. So first we'll take up this week. So for this, I have to make this, but I have to make it lightweight. Okay. So this is actually made up of mild steel. So you can check the weight. Actually, if you take this, which is lighter. So this is lighter. Can you guess what material this is? Very good. So this is as I did, that is mild steel. Okay. So if I need to make lightweight key duplicate of this, what I do? I have to go for aluminum. Okay. So since we defined the material here, okay, then I have to select the machine where I have to do. So which machine can I select for working this? Lathe. Very good. So lathe will be a good option because since the piece, what's the shape of this piece? This is cylinder. Okay. So cylindrical workpiece can easily be machined using a lathe. If you have a cylindrical workpiece, you can fix, you can use lathe. Then, since I fixed the material, I have fixed the material, now I have to choose the different types of operation to check it. So first thing is that here, so if you compare these two together, what are the difference you are seeing? One is high, it is higher than the actual piece, so I have to reduce the height. Then if you see the size, diameter, what about the diameter? Is this bigger or smaller? Smaller. So then I have to do is I have to reduce the diameter. Okay. So can you say for reducing the length, which operation I can use? Spacing. Yeah. Actually, excellent answer. To reduce the length, I have to use space. Two type of operation can be done in a group predominantly. One is spacing. For reducing the diameter, I have to go for turning. Yeah. So the difference between face and turning is that they have to reduce the length, they have to go for face. To reduce the diameter, turning. Okay. So now it is fixed. Basic operation I can do is I can reduce the length, I can reduce the diameter. Now we can make do the same step. So next thing I have to do is I have to do some other thing, make this into this. Okay. So since you said actually reducing that turning, here actually you can see different sizes, bigger, smaller, smaller, smaller. It's actually reduced in a step by step manner. So what I have to do? Very good. So I have to do step turning. So step turning is nothing but reducing the diameter in a step by step manner. If you see it's a larger in diameter, then smaller, smaller, smaller. To reduce it like this, it's called as step turning. There's also other turning called as taper turning. It's not relevant for this problem, so it's rule. So I have to do the turning. Then there is something here. So if I hold the piece here, for example, my hand is